This is a demo to present the attack to blockchain node attack scenario for the farm-to-fork platform. The attack scenario involves that the attacker gains access to the public keys of the node they are trying to insert information to or tamper with. Each quorum node runs the Tessera transaction manager, which is responsible for the management of the public keys of the nodes. Tessera exposes an IP endpoint that can give that information. Here we see the attacker making a request to the Tessera port of the node. They get as a response the peers and their public keys. From the side of the farm-to-fork platform, the network traffic is monitored via Suricata. There are special rules placed that whitelist specific IP addresses. In case an IP that is not whitelist is identified in the logs, trying to connect to one of the nodes, then the detected activity is sent to a RabbitMQ, monitored by the SACM FISHY component. Here are the logs of SACM. The SACM FISHY component receives the messages of the attempted attack to a blockchain node. Here is a closer look at the information SACM receives. SACM has information like the source IP and port of the request to the Tessera port. These will be used by FISHY to block the attacker. SACM composes a report of the attack to publish in the FISHY central repository. The report follows the CEF format of the central repository. IRO communicates with EDC and informs of the detected threat. EDC, then, creates an action for the platform to enforce against the malicious actor. Here, EDC proposes to the user to block the IP address of the malicious actor. By accepting the remediation, EDC sends to the farm-to-fork platform the command to block the malicious IP. Here, the issued action has been successfully received by the platform. As a result, the malicious user will not be able to reach the node. The next step for the attacker would be to send their transaction to the node. Here we have a basic example of how an attacker would construct an attack to a blockchain node. The attacker has to know beforehand the URL of the blockchain node, the address of the smart contract, the public key of the node they are trying to attack, the name of the function to call and its arguments, as well as the ABI of the contract. However, due to the action proposed by FISHY, the malicious user becomes unable to reach the quorum node anymore.